There were reports by a consultancy called WSP who drew attention to a number of types of information they would need to investigate the problem thoroughly. I asked Balfour Beatty to provide those, and I think they provided very little of them. Then in 2012, the Trust invited Historic England and Balfour Beatty to contribute to the costs of a report from another hydrogeology consultancy. Balfour Beatty declined, so they went ahead just between the Trust and Historic England. And this Haycock report again concluded that the problem was due to the hospital construction interfering with the groundwater flow, and they recommended that the groundwater drainage system, which was there in the design, as it appeared not to be working, should be investigated and made to work properly. On this aerial view, I've shown in yellow there the various groundwater drains that were installed when the hospital was built. So it goes all along the back of that retaining wall there, and along the back of the retaining wall of the energy centre, and then coming through those walls and flowing by gravity down into a soakaway underneath the hospital car park there. And at this point there is a drain where you can see water flowing, and Balfour Beatty have consistently said that that proves that the groundwater drainage system is working okay, so it's not their problem. But I have actually measured the flow in that drain on 2 occasions and found that it's only 6% of the design flow, and that design is also based on some very rough estimates, so one can only say that it's quite likely that that flow in that drain is not sufficient to correct the problem that's arisen with the raised water level in the well. On this diagram we can see a number of significant sites related to one another. So there's the well, and there's the retaining wall for the energy centre, which seems to have caused the acute problem. The groundwater is flowing generally in that direction. Some boreholes were installed before the hospital was built to find out what the groundwater level was. There's one there, borehole 3, another one there, borehole 2. So we have information on what the water level in those was before they built the hospital. Unfortunately, we don't have information on what the level in them is now because they've been filled in. So we've been unable to measure the current groundwater level, which would be most helpful. There's where the water gushed out in 2008. And down here at the bottom, since all these buildings, the old infirmary buildings, have been demolished, a spring has appeared in the bottom of the valley and is spreading out into a sort of algal pool. And so we've been able to relate that spring to the level of the water in the well and elsewhere. So it's all helped to build up a picture of the groundwater flow. And looking at that on this section, you can see there the well, there's the level in the various boreholes before the hospital was built. So we can imagine the groundwater flowing down that way and the level of the groundwater declining as it flows in that direction. This is what the back of the hospital looks like now, where those exploratory boreholes were, but we cannot find them anywhere. And there was another chance to find out what the level of groundwater was behind that wall. There were 2 inspection pits into the groundwater drain marked on the design plan, there and there. But can we find those? No. And in fact it appears that they never were built. So we've asked for them to be installed, but nothing's happened. So looking at the situation as we think it is now since the energy centre was built, there's the water level falling from left to right, and you can see how it's being interfered with by the energy centre retaining wall there, and the level of the water in that spring is approximately there. This is a photograph showing the same as in that previous drawing. So there's the dispensary up behind there, there's the new hospital, there's the energy centre, and there's the algal lake that's caused by the water coming out of that spring. So now moving on to what remedial actions have been proposed and what progress has been made. Haycock, the hydrology consultancy, proposed a vertical borehole close to the Hermitage well from which the water could be pumped, and that would reduce the water in the nearby well. Okay, but unfortunately you can't put it very close to the well because it's now in the middle of that busy road. The closest they can get is about 15 metres horizontally away. They would need therefore to have the well significantly deeper than the Hermitage well, and it's very difficult to know what the pumping rate would be. And of course the pumping would have to be constant, so we don't regard that as a sustainable solution and prefer a different one which involves a horizontal borehole into the hillside. Yes, an alternative would be to drill into the hillside far enough downhill so that it intercepts the groundwater, and that would need to be quite a lot longer bore than the vertical bore, but it would have the benefit of course that the water would run out under gravity and there wouldn't be any ongoing pumping costs. And it would also be a fairly simple thing to put a control valve on there so that we can adjust the level to get the right level in the Hermitage well. Whereas with the borehole with pumps, that would be slightly more difficult to achieve. So looking at it in plan here, you can see that there would be the nearest location of the vertical borehole, and the horizontal borehole would be likely to enter the ground, the hillside there beside the energy centre, and go into the hill and as far as necessary towards the Hermitage well. And there again is the spring with the algal pond. And so the location where that horizontal borehole would enter the ground is just around behind this gentleman here, who's Dave Wilcox, one of the Pontefract volunteers, and that there is Bill Hare, another one. Another possibility we have is to reduce the length of the horizontal bore by excavating into the hillside alongside this retaining wall for the energy centre. And in effect we'd be replicating what happened when they built the energy centre. We'd be digging out the hillside, that would release groundwater, then we'd build a retaining wall and incorporate within that wall a drainage facility that would enable us to drain off the water in a controlled way. So by the time that I was invited to go and investigate, that's in the spring of 2009, the water level in the well had gone up about 4 steps, and the owners, the hospital trust, had said that now we would have to install pumps within the Hermitage well to reduce the level of the water and to protect the fabric, which was fine, except that of course that was very intrusive, and the trust decided that from then on we wouldn't be able to admit the public. So it's been a considerable concern that for now 10 years we've been unable to have public open days in the Hermitage, and it would be great if we can move on to a situation where the water level is reduced without the use of those pumps and they can be removed. So to sum up, a number of hydrology and hydrogeology specialists have agreed with the conclusion that the problem was caused by the construction of the new hospital. Balfour Beatty haven't accepted that, but I believe I've pointed out the flaws in all their arguments, and they haven't supported their own argument by showing us what the water level actually is behind the retaining wall now. And we haven't been able to find that out either. But independent of Balfour Beatty, we can move on and implement a sustainable solution which will likely involve drilling a borehole or an excavation or a combination of the two in the hillside below the Hermitage and releasing the groundwater in a controlled way. But what about the funding? The Hospital Trust and Historic England have been talking about putting together an application for funding, but they haven't been able to get the information they need, it seems, to successfully do that application. Time's going by and we're looking at other possibilities, and if we could only get, say, a volunteer from the contracting industry to help us out with a special price for the work required, that would be tremendous, and they would be bound to get excellent publicity from their voluntary efforts. I would like to thank some other volunteers that have helped me on the project over the years. First, there's Dave Wilcox and Bill Hare from Pontefract, who've let me into the Hermitage many times, and there's Professor Rick Brassington, the hydrogeologist, who's visited the site and reported on his findings. There's also Professor Clive Thompson of ALS Laboratory Services, who's provided free analysis on a couple of occasions. So many thanks to them. And finally, it'll be absolutely great when we can admit the public into the Hermitage again to admire its amazing features. But it's been a long wait.